Everybody, here is the video on the solutions to the now you try problems on finding domain and range of a function given in symbolic form, but we're just looking at some linear and square root examples. So if we read the instructions, it says determine the domain and range of the following functions given in symbolic form. The first one, part A, is f of t equals -5. Here, the domain of this function is the set of all real numbers, or all the numbers from -infinity to infinity. And this is true because we can plug anything in, and no matter what we plug in, we always get out -5. And continuing on that, trying to be complete and write this word out. I often abbreviate domain just a D or DOM. And then the range is, well, the only output is -5. This never takes on anything else, so I'll say that the range is the set containing just the number -5. Part B is the function that we're looking at is g of m equals -3 times m plus 8. For this, there's no number that we can't plug in. We can plug in any number, and we are able to multiply it by -3 and add 8 to that value. So the domain of this function is the set of all real numbers, or -infinity to infinity. This function is a line. It's a straight line. It's got a negative slope, so it's going down. But it keeps going up, and it keeps going down for forever. And just with that basic information, and knowing that it doesn't skip any outputs, as we plug in different inputs, different m values for this specific function, we keep getting out all of the different y values. So the range for this is going to also be the set of all real numbers, or all the numbers from -infinity to infinity. For part C, we're looking to find the domain first, and so we want the 3x minus 4, the inside of this square root, to be greater than or equal to 0, so that I can take the square root of a positive number, or the value 0, but not a negative number. So I'll add 4 to get 3x is greater than or equal to 4, divide by 3 to get x is greater than or equal to 4/3. So I can state that the domain equals all the numbers from 4/3 to infinity, including 4/3. Now, a square root function takes on the shape of starting at the bottom left and then going in this like sideways parabola look. It's like kind of concave down, we say, but it's going up and to the right. So it keeps going up for forever. It doesn't completely flatten out ever. The larger the x value that we plug into this square root, the bigger the number is that we're going to take the square root of, and the bigger number that we're going to get out of the square root. So with that understanding, we can say that the range is going to be all the numbers starting from 0 and going up to infinity. And this starts at 0 again, because when we plug in 4/3 for x, let's show this, make sure I'm not skipping any explanation here. If I plug in capital F of 4/3, we'll get the square root of 3 times 4/3 minus 4. This equals the square root of the 3's cancel. We get 4 minus 4. That's the square root of 0 equals 0. So it does start at 0, and then it just keeps getting bigger and bigger outputs as x gets bigger and bigger. Right, one more here. Capital T of x equals the negative square root of 4 minus x. Again, we want the inside 4 minus x to be greater than or equal to 0. Go ahead and subtract the 4 to get negative x is greater than or equal to -4. And then divide by -1 to get x is less than or equal to +4. Then flip that inequality sign when I divide or multiply both sides by negative. So from this, we could state that the domain is all the numbers up to and including 4, all the numbers less than or equal to 4, or in the interval notation, the numbers from negative infinity up to 4 inclusive. Now if we plug in 4 into capital T, we get capital T of 4 equals negative square root of 4 minus 4. This is the negative square root of 0, and that just equals 0. So we know that this square root function, actually I don't want to put coordinate plane on here, it should be going down and to the right. And that's because of the negative square root, so that makes it go downward instead of upward. As the x values for the domain, as they get smaller and smaller to the left of 4, more and more negative, the inside of the square root becomes bigger and bigger, and the output of the square root also becomes bigger and bigger. And then when we negate those numbers, they become bigger and bigger negative numbers. So the range is all the numbers up to and including 0. Right? We can get all of the y values that are less than or equal to 0 for the range. Right, that's it. Again, like I said in the last video, there's a lot here, and I just want to encourage you that as we move forward, we're going to be looking for the range graphically, not by hand. We do want to be able to find the domain by hand. So go back through this, make sure you feel more and more confident about how the domain works by doing this symbolically. And hopefully you've gained a little bit. You feel like you're starting to get some sense of how to find the range, but know that we're going to do the range more graphically. And so if you're not completely following the arguments I'm making there, don't stress too much. We'll go ahead and move forward and find other ways to find the range as well. All right, thank you very much for watching, excuse me, and I will see you in the next video.